Welcome back. We're with Professor Stephen Williams of Southern Technical College, reviewing Chapter 7, which is Electromechanical Control Relays.
All right, well, electromechanical relays. Okay, so what's a relay? I like to think of it as something that can take a signal in and put many signals out. It's dependent upon the number of contacts that the relay has. You can have some with 2, you can have some with 10. Yeah, I've seen as many as 20 contacts on a particular relay. Okay, so for example, I could take a input from a push button, okay, to start a motor, and instead of starting the motor, it picks up the coil of a control relay. The control relay, in turn, has a contact on it that picks up the motor contactor, energizes the coil of the motor contactor. And it could also do a multiplicity of other things at the same time, like send a signal to remote locations to say, hey, this motor's running. Tell them that other things you can dream up as many possible scenarios as you can come up with. So an electromechanical relay is one, again, as the name applies, it's mechanical, meaning that there's moving parts involved. And it's electro, meaning that it takes in an electrical signal and energizes typically a single coil. Okay, that coil in turn puts force, either an attractive force or a repelling force, to change the state of the contacts that are associated with that relay. Typically, a control relay, every contact changes at the same time. So that is an electromechanical relay. Okay, you can have normally open contacts, you can have normally closed contacts. Normally open, 2 lines open between. Okay, normally closed, 2 lines with a slash across it saying that it's normally closed. All right, so we're taking in, it can either have an AC or a DC signal come in. It depends upon what kind of relay you want to buy. They have AC coils, DC coils, and some that can handle both AC and DC. Okay, the relays turn on the load and essentially pull the one contact together by typically, we'll get to that in a second, but typically it's going to provide an attractive force to the operating arm, and will change the position of the individual contacts. So the input, the output are separately powered. Okay, they can be powered, in which case the output circuit could be powered from AC, the input could be powered from DC. It can be any combination of the above. Okay, the relay is made up of 2 circuits, the input coil and the contact output. Relays are used for small loads. It says 15 amperes or less. Yeah, you can get some heavy duty relays that'll handle 15 amperes. Typically you're going to find them 10 amps or less, but again, that's dependent upon what you're trying to pick up. And keep in mind that you're picking up typically coil type loads, okay, so you've got an inductive loading upon it. Again, EMR for electromechanical relay, okay, Horn relay, and again, these are posted previously as far as the actual PowerPoints are concerned, so you can go through them at your leisure. There's many different types and sizes. I've seen them as small as what they call an ice cube relay here. Okay, that could be anywhere from 1 inch tall and 1/2 inch square.
Do they call it an ice cube relay because it's clear on the outside?
Yeah, because it looks like an ice cube and you can see through it. Now, I've also got relays that, quite frankly, are, say, a foot tall by a foot wide and have many, many different contacts in them. And again, it depends upon what your uses are and what the standards are. Every company tends to have a different set of standards that they use, different manufacturers of relays to try to keep, again, things consistent from one place to another. Okay, you always have, we'll see this again, you've got your contact connections here and you've got your coil connections here. Can't really see it very well in this picture, but the coil connections are turned in a different direction than the contact connections to make it easy to, when you plug it into a base, the base has the screw terminals on it where you're attaching your wires. Now this, your wires attach directly, and this happens to be a contactor, meaning that it's intended to pick up more than just a light load. Okay, a control relay is intended to pick up a light load. The ideal thing, they have a DIN rail, and this came into being when we started doing the metric conversions, getting involved with the German companies, manufacturers. Okay, it's pretty widely used at this point. DIN rail is just a name, I'm not sure what it stands for, but it is essentially universal. They use it to mount a variety of devices. You can see in this case, you can mount relays. These happen to be control relays. Okay, you can mount terminal blocks. You can mount timing relays. And the nice thing is you can butt them all up against each other and get an awful lot of equipment in a very neat, compact way. And they're fairly easy. You don't have to strip out the whole thing to replace one. You can actually pop it off the DIN reel and stick one right back in where it came from. So if you have one bad relay you got to change out, it's fairly simple to change it out. You have a bad terminal block, you have a bad fuse block, you can turn them out. So it's a real time saver. Okay, now you can see here the electromechanical relay. It's got stationary and movable contacts. Okay, the movable contacts, stationary contacts, these are ones that are stationary, tells you that they stand still, all right? So we have a coil down here. When we energize that coil, it provides a attractive force, and that attractive force pulls the magnet down, closing the contacts. When that coil is de-energized, the magnetic attraction goes away and the spring will pop the contacts apart. So it's a pretty simple operation. And depending upon the, this could be really tiny depending upon the size of the relay, or it could be fairly heavy duty depending upon the size of the relay. Okay, as the name applies, you've got normally open, normally closed contacts. Some of them are being pulled in. If we go back to the previous slide, where you've got two contact surfaces are meeting up at the same time. You've got other ones that can change positions from open to close and have a common swing arm on it. Okay, so it's many different varieties of types of contacts. Okay, again, the armature's getting pulled in. As it gets pulled in, it's going to change position. Okay, or in this case, it's being repelled. Okay, so when the coil is de-energized, it's repelled by the spring, and when it's energized, it's attracted. Okay, so this would be a normally closed contact, normally open, and it's sitting there, And once the armature is energized, it's attracted to the coil and the contacts change position. This is the big picture of what I want you to get out of this, the electromagnetic part. Let's flip through here, see if there's anything else out there. Okay, sometimes the contacts are numbered. And again, there's different methodologies used by different manufacturers. Some, they let you mark your own contact numbers on it. And sometimes the only way you can tell is by the numbers on the wires themselves. So the first contact is CR1, 1 CR, okay, telling you it's the first control relay. Or sometimes it'll be a CR1, TAC1, and it depends upon the engineering company and how they want to call their things. All right, and you can see you can have all different kinds of combinations. All right, some of the contacts, believe it or not, you can convert them from normally open to normally closed. And I've seen several different manufacturers have those kinds of contacts, and there is no one set methodology that's used for changing them in place. So you need to be familiar with that particular manufacturer and how they work. But essentially, like it shows here, you pull the cover off, and a lot of times you're just flipping them around the other direction, and you're changing it from a normally open to a normally closed contact. You can see here, one control relay is controlling 4 different contacts. Okay, or it can control as many as the relay has on it. Relay applications, there are as many as you can possibly think of. You can use a relay to pick up a starter, to pick up another relay to be picked up by a switch, a limit switch, a pressure switch, a temperature switch, a flow switch, a level switch, doesn't matter. I mean, there's 100 million different ways you could use them. Going back there, the relay coil consumes a fraction of a watt of power, while the contacts may be able to conduct hundreds of times the amount of power. Yeah, it's true. Okay. Again, as I said, I tried to say in the thing before, a relay would generally not be used for a 480 volt load. A relay is typically a control device. You don't use it for 480 volt. Why? Because when you're dealing with control, you're usually dealing with 120 volt or lower. And when you stick 480 volt where everybody's expecting to see 120 volt, disaster. Okay, things can happen that are unexpected and people can get hurt. They can control relatively high current with a low current. Okay, I'm not talking hundreds of amperes. Again, we're talking 5, 10, 15 amps tops. Okay, now they're showing here a comparison to a relay with the transistor. Again, we're kind of mixing metaphors here, so I'm going to move out. Again, you can control as many things as you could possibly think of. All right, and there's so many different varieties of things you can have out there. The big thing I want you to get out of it is it's a mechanical device. It's controlled by a coil. The coil is energized. It attracts the armature. The armature moves the state of the contacts from one point to another. You've got normally open, normally closed, and a control relay. The designation on a drawing is always shelf state. Coil de-energized. Okay. With that, that's all I'm going to talk about on this particular one. but I'm gonna start on another one here, if I can get there. Nope.
We'll come back
Yeah,
after a
we'll come
short break.
back.